Okay, so in this video, we'll be talking about combinations. And before that, let's review what permutations are first. Recall that when we take a permutation of k things, or I should say of n things, taken k at a time. This is really the same thing as saying if you start with n objects, let's call them a1 to an, how many ways are there to pick k of them and put them in a row in some specified order? Right? And so in this case, we will say order matters. Right? Because if I just switch a2 and an in the first two spots, that would count as a different result in terms of permutations. Now for combinations, the only difference is that the order does not matter. Right? So the order in which we're taking these objects. And so instead of putting them in a row like this, can simply imagine us just placing them into a set of size k, where it doesn't matter which element got put there first, right? As long as it's in the set, then it's in the set, and the order does not matter. And well, we know how to deal with this, right? What we basically have to do is say, for each possible set that you're getting here on the right, how many times would this appear as a permutation? Well, if there are k things in this set, then there are k factorial ways of ordering them. And so really what this means is this npk term that we have for permutations overcounts the number of combinations by exactly k factorial. And so that's what we will define as the number of combinations of n things taken k at a time. We will denote this by nck, or by using this big pair of parentheses with n on top and k on the bottom. We'll talk more about this later on. And this is simply npk divided by k factorial, which is n factorial over n minus k factorial times k factorial. All right, so again, just the same thing that you're counting. The only difference is that instead of an ordered k tuple, it's just a size of set k. And to give you a concrete example here, so if you look at the first question and the second question, one of these will be answered by a permutation and the other by a combination. So if you'd like, you can pause the video now and try to read the question and figure out for yourself first which is which. Okay, and so you can pause it now. Okay, so again, the key thing to really check here is whether order matters. And so if you look at the first question, you have a class of 30 students, and among the 30, you're selecting 3 of them to represent them on a student council committee. Right? And so really what you're doing is you're just picking 3 people. And well, we don't make a distinction among the 3. Right? The 3 of them will form a committee, or will form a team that you're sending to the committee. regardless of who was picked first, second, or third. They're either in the team or not. And so here, this is an example of a situation where order does not matter. And so in this case, it is a combination of 30 things taken 3 at a time, or 30 choose 3. Since order in which the student representatives are picked does not matter. Whereas for number 2 here, you are actually electing now students to 3 positions: class president, vice president, and a social media representative. So in this case, you could pick 3 people, say A, B, and C, in that order, and that would denote a different outcome than picking, say, C first, and then A, and then B. Right? If you think about it as whoever you pick first is going to be the president, and then the VP for the next one, and then social media for the last one. Right? So these are 2 different outcomes. So here order matters, therefore it's 30p3. Or in other words, it's 30 factorial over 27 factorial. Okay, so I'll just write that down since order matters here. Let's look at another example where we see combinations. And this is an example where you have a standard deck of cards. Right, so a standard deck has 52 cards. There are 13 ranks and 4 suits for each rank. So clubs, spades, hearts, and diamonds are the suits. The 13 ranks are ace, 2 to 10, jack, queen, and king. And the first question is simply how many 5-card hands can be formed from a standard deck? Right, so you have a standard deck of 52. Right, so that's a deck of cards. I don't know, that's a heart. And say you're picking 5. Now, when we say that you're picking a 5-card hand, well, you're holding the 5 cards in your hand, and the order in which you hold them doesn't matter. Right, so for example, I can draw a 5-card hand. Let's say, well, I'll use red here. Let's say I pick 4 of hearts, and then the 7 of diamonds, and then the jack of hearts, and then ace of spades. Harder to draw. I'll just draw a heart, 2 of hearts. Right, so in this case, that's a 5-card hand. And assuming you drew 4, 7, jack, ace, and then 2, if you drew the 7 first, and then the 4, and then the same cards afterwards, well, those would be counted as the same hand. Right, and hence that's why we say the order does not matter when you're counting how many 5-card hands you can form. Therefore, the answer there is, well, you have 52 things, and you're picking 5 from them, where order doesn't matter. Therefore, it's a combination. Now for part B here, how many of these 5-card hands contain only numbered cards? Okay, by numbered, we mean 2, 3, 4, all the way to 10, and only those cards. And so it's the same idea. You're still forming a 5-card hand such that order doesn't matter, but you're not picking from 52 anymore. Instead, you're only picking from, well, how many numbered cards are there? There are 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 numbered ranks. So a total of 36 numbered cards in the deck. Therefore, there are 36 C5 such hands. Okay. And part C here is, well, it's dealt with in the same manner. You're forming a 5-card hand where you have exactly 2 red and 3 black cards. Right, so the clubs and the spades are the black suits, the hearts and the diamonds are the red suits. So it's the same thing as part B, but here you have to use the product rule, because there are 2 steps to this operation. Step 1, you pick 2 red cards. Step 2, you pick 3 black. And how many ways are there to pick 2 red cards? Well, how many do you have? You have 26, which is 52 divided by 2. So there's 26C2. 3 black cards is 26C3. So by the product rule, the number of such hands is 26C2 times 26C3.